So in the last few videos, we were talking about numbers like 10 to the ninth and 10 to the sixth, and we were saying they mean things like billion and million, and 10 to the third is 1,000. But I wanted to take a video to kind of explain what these numbers mean because they're kind of hard to comprehend. So let's go ahead and start writing these out. Let's compare 1,000 to a million to a billion. See if I can spell that correctly. And let's compare that to a trillion, just to give you an idea of what the difference between these numbers are. And so we'll say versus, and versus, and versus. And so 1,000 is obviously a 1 and 3 zeros. A million is 6 zeros. And then a billion is 9 zeros. And of course, a trillion would therefore be 12 zeros. And in scientific notation, this would be 10 to the third, a million would be 10 to the sixth, a billion would be 10 to the ninth, and a trillion would be 10 to the 12th, which is kind of why we have scientific notation in the first place. It's a lot easier to write 10 to the 12th than it is to write 1 and then 12 zeros. But we look at these numbers and we think, okay, they have different numbers of zeros, that's the difference, and they're all really big numbers. But what actually is the difference between these? And to answer that, I want to ask a question. How long would it take to count to 1,000 seconds? And so if we pull out our handy dandy calculator, we can actually figure that out. We can type in 1,000, and we can divide that by 60 seconds in a minute to get how many minutes it would take to count to 1,000, and it's almost 17 minutes. And so I'm going to say around 17 minutes. And so if I counted 1, 2, 3, 4, all the way to 1,000, it would take me 17 minutes to count 1,000 seconds. But what about a million seconds? How long would it take me to count to 1 million seconds if it only takes me 17 minutes to count to 1,000 seconds? So if we pull out our handy dandy calculator, we can take 1 million, so that's a 1 and 6 zeros, and we divide that by 60 because there are 60 seconds in a minute. We get almost 17,000 minutes. And if we divide that by 60 because there are 60 minutes in an hour, we get about 278 hours. And if we divide that by 24 hours in a day, we would get 11.57 days, or almost 12 days to count to a million seconds. And that's a huge jump. We went from 1,000 seconds in 17 minutes to a million seconds would take 12 days. And so what about a billion seconds? And I'm not going to take the time to write out all those zeros. There's too many to write, and I'm running out of room on the left side over here. But a billion seconds, what would this take? And so to write out a billion in our calculator, we'd need a 1 and 9 zeros. And so we got 3, 6, 9 zeros. And we divide that by 60 seconds in a minute. And we divide that by 60 minutes in an hour. And we divide that by 24 hours in a day. And we would get about 11,574 days to count to a billion seconds. And so I'm going to divide that by 365 days in a year. And we get almost 32 years to count to a billion seconds. And so to put that in perspective for you, if you haven't been alive for 32 years, then you haven't been alive for a billion seconds yet. And so what about, then, a trillion seconds? How long would it take to count to a trillion if you counted 1 every second? Well, if you haven't figured it out yet, each time it multiplies by 1,000. And so if you look, we got almost 12,000 days, which equals 32 years. And you may recall that 12 days was almost 17,000 minutes. And so each time it's going up by 1,000. In other words, a trillion seconds would take almost 32,000 years. To put that into perspective, the last ice age ended a little over 10,000 years ago. And you know the animal, the dog? Dogs were domesticated from wolves into dogs about 30,000 years ago. So, in other words, dogs became dogs from wolves about a trillion seconds ago. That's how big a trillion is, and that's the difference between these various numbers. So for example, the difference between 10 to the third and 10 to the ninth is just 6 exponents. But really, the difference between 10 to the third and 10 to the ninth is the difference between about this video and the last video you watched, and from the time you are born all the way through high school, all the way through college, and then 10 years into your career. That's the difference between 6 exponents. And if you think about it, that's the difference between 10 to the 6th and 10 to the 12th. It's a million times bigger. And the difference between 10 to the negative third and 10 to the third, that's about a million times bigger as well. It just looks like it's 6 exponents different, but the difference between these two numbers is the same as the difference between these two numbers. So when you go from 10 to the negative third to 10 to the third, that's like saying the difference between 17 minutes and 32 years. Yes, they are all big, and yes, it's kind of hard to comprehend the difference, but hopefully this video helped you a little bit in understanding how different these numbers really are.